Welcome back to part 2 of non-algebraic. Wow, what a long day. Not even a minute in. Welcome back to part 2 of angle proofs. We are going to jump right in and just start applying and talking through some of these so that we use our time as best as possible. So if you're in my class, then you potentially have access to these notes already. If not, then you might want to take advantage of pausing this video so that you can jot these down and label the diagram. So the first thing we know is that we are given ray DB bisects angle ADC. So first thing I'm going to do is I'm going to go to my diagram. If I need to draw it, I'm going to draw it. But I am going to trace out ray DB. Ray DB and how it bisects angle ADC. Now, why do I do that? Because if the diagram tells me that bisects angle ADC, then that means it is cutting that angle into two congruent angles or into two smaller equal angle measures. And so that is what I'm given. And then I want to prove that the measure of angle 2 is congruent to the measure of angle 3. Okay, so step 1, I am given that ray DB. You need to make sure that you draw a ray symbol over top of that so that you are actually notating that it's a ray. But ray DB bisects angle ADC. How do I know that? Step 1, it is given to me. I always want to put my given in my first step because I want to milk the given for all that it is worth. And what is it worth? Ray DB bisects angle ADC. Because of that, I know that angle, gosh, we have yard work happening outside of our door right now. My apologies. Because of that, I know that angle, hey baby, and a child talking. Because of that, I know that angle ADB or angle 1 is congruent to angle BDC or angle 2. Because my proof statement is involving the numerical names, because it's involving the numerical names of these angles, I'm going to use those. So I'm going to say angle 1 is congruent to angle 2. Right? And I know that. How do I know that? Well, I know that because of the definition of a bisector. If you have a very particular instructor, then they're going to want you to put the definition of an angle bisector. I'm okay with the generic statement because a bisector, whether it's bisecting an angle or a segment, Everly, nobody wants to hear you do that, baby. Can you be patient? Thank you. The definition of a bisector, regardless, cuts whatever it's bisecting into two congruent pieces or two equal measures. Okay? So the definition of a bisector will work just fine for my classes, but if you need something specific, you'll need to put definition of angle bisector there. Okay? So then the next thing that I want to go for is anything that will bring angle 3 into my problem. Well, most ones are, Faith, why do you say that? Well, my proof statement involves angle 3, and I can't prove anything about angle 3 unless I bring it into the actual proof. And so when I'm looking at this diagram, 2 and 3 aren't a linear pair because there's another angle here. They're not adjacent angles, so they definitely can't be a linear pair. I don't know if they're supplementary. Angle 1 and angle 2 aren't supplementary. They're not a linear pair. But if I start looking a little more at angle 1 and angle 3, I do notice that they are vertical angles. Okay. So listen, if you have a very particular or a very strict, follow all the rules and theorems of geometry, your next step would have to say angle 1 and angle 3 are vertical angles. Justification, or on the right side, definition of vertical angles. Okay. Then you would have to say angle 1 is congruent to angle 3 by the vertical angles theorem. I'm going to go straight to that step. I'm going to say angle 1 is congruent to angle 3. And how am I able to say that? I can say that because of the vertical angles theorem. Again, I'm not going to forget my congruency sign because that will drive the state of my justifications. Like for instance, my next step, look at this, step 4. I need to say angle 2 is congruent to angle 3, and I'm really close. What I notice if I look up above, if I start looking at what I've already proven, I've got angle 1 and angle 1 right here. In step 2, angle 1 is congruent to angle 2. But in step 3, angle 1 is congruent to angle 3. Now I should be able to, by one of those properties that we know, I should be able to say, if these two are congruent, then these two are congruent. I cannot use substitution because substitution only works for equality statements. These are congruency statements. So substitution is not going to work here. It will be counted wrong unless you go back and convert those to the measures of angles. Then you can do substitution. Then you can convert them back to a congruency statement. That's going to take you probably 7 or 8 steps though. Or you can say angle 2 is congruent to angle 3. How am I able to do that? How am I able to state angle 2 is congruent to angle 3? I'm able to state that by the transitive property of congruence. Why is it POC, property of congruence, and not POE? Because I'm dealing with a congruency sign. Okay. And that's what I'm trying to prove. It's the last step in my proof, and I'm done. Okay. Now, for the sake of those of you that may not have followed where that came from, I'm going to keep going. I'm going to say, okay, maybe I didn't do step 4. So I'm going to pick up at step 3 and I'm going to do it differently. I'm going to convert steps 2 and 3 into measures. So I'm going to say the measure of angle 1 equals the measure of angle 2, and the measure of angle 1 equals the measure of angle 3. I'm able to do that by the definition of congruency. If you've got a particular instructor, then they're going to say the definition of congruent angles is what is required. Then I can say the measure of angle 2 equals the measure of angle 3. And I can say that that is by substitution, property of equality, or transitive property of equality. That's because I've converted them into equal statements. Then my last step would have to be angle 2 is congruent to angle 3. Why? Again, because of the definition of congruency. So I just wanted to break that proof down 2 different ways to show you that you do have some autonomy. You can choose how you want to do this. One method is going to take 4 steps. The other method is going to take 6 steps. You still arrive at the same answer, but it's just a matter of what did you see? What tools in your toolbox did you see that you could use, and then using them correctly. Okay, so there's our first proof. You might want to pause this video if you didn't quite catch it, or if you need to rewind, then rewind and pause at each step and go from there. Otherwise, I'm going to keep moving on. So here we go. Okay. So this next part, pause the video so that you can draw and label the diagram and set up your proof, and then we will go from there. All right. So step 1, I am given that angle AEC is congruent to angle DEB. How do I know this is my first step? Because my first step in a proof is always my given. And in this case, they didn't start us out with much. So we're going to have to get creative here. However, we should be able to still figure this out. If we remember anything from segment proofs, we remember the pattern. Given, label the diagram with the given. Usually, or oftentimes, our very next step was segment addition postulate, substitution, finish the problem. This is another one of those instances. I'm not given much. I'm given angle AEC. So this angle is congruent to angle DEB. And that's it. I'm not working with linear pairs. I don't have any vertical angles. I don't have any complementary or supplementary angles. I have adjacent angles, but adjacent angles don't have any numerical value, meaning they don't add up to anything or they're not congruent. They just share a vertex and a side. So we're going to have to get creative here. If none of those angle pair relationships work, then our next step might just have to be angle addition postulate. And so that may be where we want to start. That's where I'm going to start. Actually, that's not where I'm going to start. Remember how I always said to milk what you are given, milk it for all it's worth? Well, I've got congruent angles here. If I want any chance of substituting, I probably want to convert those right here while I'm working with them. So that's what I'm going to actually do in my next step, is convert those using the definition of congruency, or specifically definition of congruent angles. Now my next step, I'm going to say the measure of angle AEB plus the measure of angle, let's say BEC. That equals the measure of angle. I'm going to use the exact same notation that's given to me, AEC. Could I have rewritten that a different way? Sure. You could have written it as A or CEA, but then it wouldn't be written exactly like the proof gives it to you, and then you'd have to rework some stuff. So I'm going to advise that you keep the notation or the name, the written name of your angles. I'm going to advise that you keep it written that way as much as possible, unless the proof demands that you do something else. Okay. So I've got AEB, the measure of angle AEB plus the measure of BEC equals this total. Notice that that includes what's given to me. That's a good sign. That means that I'm going to be able to substitute some things. So that's really great. Okay. I'm also see that I could do angle addition postulate over here with these two angles. So I'm also going to include that. It can't hurt. It will probably most likely help. So I'm going to say the measure of angle DEC plus the measure of angle, let's say BEC equals the measure of angle DEB. It starts to get a little funky there. You always want to make sure you keep your notation, because think about it. If I would have written CEB, how many of you would notice that those are the exact same angle? It would have been hard for me to notice that, but you want to be able to notice that so you can substitute them, or so that you can say, okay, those two pieces are equal, so maybe something else is also equal. That's all I'm saying about naming your angles consistently throughout the problem. It'll just keep it cleaner and easier to follow. I'm able to do step 3 because of the angle addition postulate. Now, let's take a step back and let's evaluate what we actually have. Okay. So some things that I immediately see, I've got the measure of angle BEC in both of those places. They're two different equations, and yet those things are equal. I also see this is what I'm trying to prove. So this is a really good sign. Those two pieces are equal. I want to prove these two are equal. All that's left to make that possible is this. If those two are equal, then I am in the back stretch and I am close to being done. I want you to look at what was given to you, more specifically, what you got from the given. There's the measure of angle AEC. There it is again. Here's the measure of angle DEB. There it is again. I know that those two things are equal, which means these two things here are equal. It also means that I can substitute one for the other. That's what I'm going to do. I'm going to say, I'm going to just pick this second statement actually to manipulate, and I'll show you why here in a second. I'm going to say the measure of angle DEC plus the measure of angle BEC equals, instead of DEB, I'm going to say it equals the measure of this, because they are equal to each other. So by substitution, I can take DEB out and I can put AEC in its place by substitution, property of equality. So now check out what we have. These two are equal. And now these two things are equal. Shoot, I messed that up. Here we go. My apologies, people. I got these two things equal. You know what? Let me back up. I don't like what I just did there. So I know that that probably frustrates some of y'all, but that is the name in the game of proofs, is looking at what you did and then deciding if you want to keep it that way or not. So I'm actually going to change this up. I'm going to, let's see. I want to change up what I wrote is what I'm trying to say. So let's see. Sorry, y'all, I had to pause that. I had to figure out where I was. That happens sometimes with proofs. So it's important that you're able to just pause, maybe step away from it. If you're on a test, maybe go to a different problem and then come back and revisit it if you need to. Or if you just get completely stuck, then it may be a good idea to erase one or two steps and start again. Okay. Luckily, I figured out what I was going for. I just had some distractions in the form of children and dogs, but we got it under control. So here is what I want you to see now. Okay. Notice from this top step 3 and step 4 that those are still the same. But now notice, because of substitution, this and this are also the same. So if everything else about those two equations is equal, then that's going to force these two things to also be equal. Okay. And why are they equal? The measure of angle AEB is equal to the measure of angle DEB. Why is that possible? That is possible because of the transitive property of equality. Now, if that step bothers you, you don't have to go to that step. You can take it a little bit further. 4.5 is an optional step, but you could say, all right, I'm going to subtract Beck away. So I'm going to say the measure of angle, I'm going to say the measure of angle AEB equals the measure of angle AEC minus the measure of angle Beck. And I'm going to say for step 4, the measure of angle DEC equals the measure of AEC minus Beck. And I'm able to do those things because of the subtraction property of equality. And so once you have that step, then you could say, okay, now I've got one side of both equations completely equal. Now I can say that AEB and DEC are equal by the transitive property or by substitution. Okay, so you could definitely take this step here. What I need everyone to see is, if you don't take that step 4.5, if you don't take that step 4.5 and you just go straight to 5, that is only by the transitive property, because you don't have anything specifically that you're substituting in. You're taking two equations and you're condensing them into one. So the transitive property of equality is allowing you to skip that 4.5 step. It's allowing you to skip subtracting on both sides and then substituting. Okay. Now, that is not what we're trying to prove. What we have are equal measures of angles. What we're trying to prove are congruent angle names themselves. No, ma'am. No, ma'am, that's not yours. No. So for me to completely finish this proof, I've got to say angle, the name angle AEB is congruent to angle DEB. And I'm able to convert back and forth between equality and congruency using the definition of congruency. Okay. And so there's our second proof. Okay. All right, so moving on. I think I might have, yeah, I typed this one out so we can walk through it step by step. So here we go. Pause the video if you need to write out what you're given, what you're trying to prove, and to draw and label your diagram. Okay. Now, if you've already paused it to draw and label those things, we've done one similar to this. I think it was either earlier in this part 2 lesson or back in the part 1 lesson on angle proofs. So I want you to pause this video and see what you come up with for this proof. And then I will reveal one option that you may have in this proof. So pause this video, see if you can come up with a solution that starts with the given and ends with what you were trying to prove. And then you can unpause the video to see one possible option. Please be reminded that that upside down T, that literally is forming perpendicular lines. That's the symbol for perpendicular. So you're trying to prove that line or segment BD is perpendicular to segment AC. Remember that perpendicular lines form right angles. So that should be a huge hint if you need one. Pause the video and try this proof out. And so here is one possible option for the solution to this proof. Notice that the measure of angle 1 is 90 degrees, and you are given also angle 1 and angle 2 form a linear pair. So that's what I'm starting out being given to myself. If I label my diagram, the best way to label this is the measure of angle 1 is 90 degrees. Well, I know that that means that that's a right angle. And if angle 1 and angle 2 are a linear pair, then that means angle 2 also has to be 90 degrees, which is another right angle. So I'm given that and I labeled it. Step 2, in this situation, I went straight to angle 1 and angle 2's measures add up to 180 degrees. And that can be either the supplement theorem, or if you are some of my students, I will take definition of linear pair, just because I'm not too particular about that. But some students may be, with other teachers they may be. Then the next thing I did was I saw that I was given the measure of angle 1 is 90 degrees. I'm given that measurement for a reason, and it is so I can take it from here and substitute it in. So that's why in step 3, the measure of angle 1 is gone, and I plug in 90 degrees in its place. Subtract 90 on both sides by the subtraction property of equality. That is showing that the measure of angle 2 is 90 degrees. And if angle 1 and angle 2 are both 90 degrees or both right angles, then that means that segment BD is perpendicular to segment AC. Why? Because perpendicular lines form right angles. Definition of perpendicular lines. Now here's another option that you could have taken. For those of you that have a very particular instructor, this is a very specific way that you could have outlined this. For those of you that have me specifically as students, this is just another way that you could have done it as well. So you're given angle 1 and angle 2 form a linear pair. So I'm going to say that those are supplementary by the definition, but then they also add up to 180 degrees. I could say that that's by the definition of supplementary angles, and I'd be totally fine. I'd be absolutely correct. Okay. Then the measure of angle 1 is 90 degrees. That's the given. Okay. Notice that that's okay to put there. If it was me, I would put all of my given in step 1, but you are not required to. You just have to start with some of the given. Then take your definition or your step 3, substitute 90 degrees in, subtract on both sides, and you get your perpendicular lines again. So that proof that we just completed, that you just attempted on your own, that I showed you a couple options for, that is playing on this idea of this theorem. And it doesn't really have a specific name necessarily. It's just a statement. Perpendicular lines intersect to form 4 right angles. Okay. So you'll need to remember that. You also need to remember that all right angles are congruent. So in this, if I back up to this proof, what if it said instead of prove this, what if it said, oh, that was a really bad line. Let me try again. Here we go. What if instead it said, prove that AC and DB form 4 right angles? What if that's what the proof statement was? Then we would have to come down here and we would have to say, you know, everything that we did is perfectly fine, but then our last step would have to say AC and DB form 4 right angles. Why? Because perpendicular lines form 4 right angles. So it's just a slight change in the prove statement, but it's going to require some extra work. It's going to require knowing these theorems like this. Okay. That is the end of part 2 of angle proofs. And there are so many angle proofs out there that we could do, that you could find. If you have any questions, my students, feel free to email me. If you're watching this on YouTube, feel free to comment, and I may try to make some more. Who knows? But that's it. End of part 2. Have a good one.